In naming alkanes, it is necessary for you to know the definition of alkanes. So, alkanes are aliphatic hydrocarbons having carbon to carbon and carbon to hydrogen sigma bond. They can be categorized as acyclic or cyclic. So, there are two types of alkanes. It can be acyclic alkanes, it can also be cyclic alkanes. So, acyclic alkanes means it contains linear and branched chains of carbon atoms. It has a molecular formula of CnH2n plus 2. So, for example, to be able to visualize alkanes, acyclic alkanes, we have here propane. Propane has a CH 3 CH3 CH2 and CH3. So it has a linear chain of carbon atoms. That's why it is part of the acyclic alkanes. When we say cyclic alkanes, it has a one or more rings. For example, we have here cyclohexane. It is in a form of ring. That too is why it is part of cyclic alkanes. Now, in straight chain alkanes, we will base it on the number of carbon atoms. So, for the first one, I will be giving you this. So we have here, as you can see, we have a one carbon atom. So we'll put one carbon atom, and the name of this is methane. If we put the content structure, it will be like this. We have one carbon and 3 hydrogen. Next. So for the next one, this is ethane. As you can see, we have here 2 carbons. So put 2 here. And then the name, it's ethane. This is a parent name. And since it is alkane, we will add ane. Look here first before writing the content structure. So we have 1 C and 3 hydrogen around it. And for the next carbon, we have C and 3 hydrogen around it. That's why it has a content structure of CH3 and CH3. Next, for the third one, it is named as propane. Prop as a parent name, ane as it is part of the alkane group. So for the propane, we have 3 carbon atoms. Then, after putting the carbon atoms, we will surround it with hydrogen. And as you can see, we have here 3 carbon atoms. So we will put 3 here. And then for the content structure, we will first look at this part, this, and then this. So we'll start at C, H3, as you can see here. And then write C for this one, and then since it is surrounded by 2 hydrogen, we will put 2 hydrogen. It is surrounded by 2 hydrogen. Next, we will then write this part. So we have here 1 carbon and 3 hydrogen. Next, so for the fourth one, it is named as butane. BUT as the parent name, then ane as it is part of the alkane group. So we have here, for butane we have 4 carbon atoms and it will be surrounded by hydrogen. So how many carbons do we have? We have here 4. So we'll be writing here 4. And then for the quantum structure, we will start here, then here, and then here. So first we have CH3, CH2, CH2, and then CH3. Next, as you can see, if we have 5, it will be named as pentane. If we have 6, it will be named as hexane. If we have 7, it will be named as heptane. If we have 8 carbon atoms, it will be named as octane. We have 9 carbon atoms, it will be named as nonane. If we have 10, it will be named as decane. So yeah, that's it. In naming alkanes with substituent, I think it is necessary for you to know and to know how to find the parent carbon chain. So in finding the parent carbon chain, you need to locate the longest carbon chain you can find. For instance, we have here this. We have here this and this. So there are different ways on how you can find the parent carbon chain. So you can start here. You can also start here as well. You can so you can start here in this direction. You can also start by here. You can also start here or here. We're also here. But the most important that you need to know is that you need to find the longest carbon chain you can find. Let me see. Wait. You need to find the longest chain that you can find. For example, we will find the parent chain by numbering like this. So we will number how many carbon chains it has. So it's 1, 2, 3, 4, 5, 6, 7, 8. We have here 8 carbon chain. We have here 8 atoms. Then we can also start by we can also start here. Yes. So if you think about it, you can number. So 1, 2, 3, 4, 5, 6. 6 atoms or carbon chain. 6 carbons. We can also start, since our goal is to find the longest one. Wait, just gonna delete this. Wait. So, since our goal is to find the longest carbon chain, we need to find something longer than 8. So we can also start here, by here. Let's see if it is longer than 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. Basically, it's the same. So it still has the 8 carbon chain. So we are looking for something longer than 8. We can also start here to here. Let's see if it is longer than 8. 1, 2, 3, wait. I'll just use this. We can number it. We can see if it is longer than 8. So we have 1, 2, 3, 4, 5, 6, 7. It is a 7 carbon. And as you can see, 8 is longer than 7. So this will be the parent chain. You just need to look for the longest parent chain that you can find. That's it. Then this part, after you're done finding the parent chain, you will locate the substituents. So what do you mean by substituents? It is the one that is attached to the parent chain. So this is what you call a substituent, and substituent.